Okay, since we're here, let's write down the ones that we wrote down on Friday too. I'll just write here. I'm out of room, so. Oh, man. Okay, sine squared x plus cosine squared x equals 1. That's one of our Pythagorean identities. Do you guys remember how to prove the next two? Which should we divide everything by? Sine squared. Sine squared divided by sine squared is 1. Cosine squared divided by sine squared is cotangent squared. And 1 divided by sine squared is cosecant squared x. And how about the last one? What do I need to divide everything by? Cosine squared? So sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1. 1 divided by cosine squared is secant squared. Okay, let's prove one. Let's say on the test you blank out. You're like, I thought I knew them, and all of a sudden you need it and you just don't know it anymore. Okay? You just literally blank out. You can actually prove it. It's not hard at all. Let's prove this one. We'll just do it right here, okay? So the derivative of tangent, and somehow we have to get secant squared. What's another way of writing tangent? Sine over cosine. Well, that's a quotient, right? Do you guys still remember the quotient rule? Low d high minus high d low over low squared. Quickly do it. And perform that. Low d high minus high d low over low squared. What is that again? What, the yellow information? It's 1, right? We just wrote it down. It's right here. And what is 1 over cosine called? Secant, and it's squared, so secant squared x. So we were able to show that the left side is equal to the right side. Just using the quotient rule, right? So if you blank out, if you completely just lose it, you can still prove it. Okay? You can do that for all of them. The homework was just passed out. It has no chain rule, so this homework should be much easier than the other homeworks. Let's do a tangent line problem. So you guys get to choose. Which one looks harder, 21, 22, 23, or 24? Sure. You have it in front of you. 22? Okay, let's do 22. I mentioned every homework from now on is going to have a small section for tangent lines. The first thing we need is a point, and that was given. Yay. The second thing we need is a slope, which really means the derivative evaluated at x equals what for this problem? 0. So I'm going to do that for me. Find me the derivative. Once you have it, plug in 0 immediately. Don't bother simplifying it, okay? So I'll slow down a little bit. So it was the first to the second plus the second to the first. I'm going to plug in 0 into every x spot. E to the 0 is 1. Negative sine of 0 plus cosine of 0. E to the 0 is 1, so I just write 1. So unit circle, right? Sine of 0 is clearly 0 plus 1. The answer is 1. The last thing we need is y minus 1 equals 1, x minus 0. Questions on part A, B, or C? Okay, so this homework should be considerably easier than the homework because it has no chain rule, okay? Every problem was created so that there was no chain rule required. Cool. All you're really doing here is you're practicing the product rule, quotient rule with trigonometry. And again, I highly encourage you to do this first. Memorize, make sure you know all those, and then start the homework. That way you're just reinforcing what you already know. Versus the student that's constantly looking at their notes, hasn't memorized anything, right? And now they have to memorize it the night before the test. Test the next day, there's a lot of pressure. Sometimes you blank out. Big difference, right? Okay. That was lesson number 1. Lesson number 2, we're going to go back to limits, but now they're going to be much, much easier. Okay? So here we go. This is lesson number 2. So this mathematician, L'Hopital, came up with a clever way of finding limits of anything that's super complicated. But it does have to fit in this formula. It does have to be a 0 over 0 problem or any infinity over any infinity problem. There's more cases, but that's all you need to learn this year, okay? Example. We're going to do this one twice. The limit as x approaches 3, x squared minus 9 over x minus 3. We've seen this, right? We've probably done this problem a few times now. Would you agree it is 0 over 0? So L'Hopital said, okay, let's see who is changing faster. So a derivative not only tells me the slope of the tangent line, it tells me how something is changing. If you're in physics, it's our delta x over our delta y, how fast something is changing. Sorry, it's backwards. Delta y over delta x. So we're going to take the limit as x approaches 3. And here's basically what you need to do. What's the derivative of the yellow? Just the yellow, no quotient rule. 2x. What's the derivative of the green? 1. Now we're going to try to take the limit again. So if you remember, the first time it failed because it gave me 0 over 0. What happens when I plug it in now? 6, and that's the answer. Our old way looks like this. We would get rid of it, right? And then plug in 3, and same thing. What happens when I plug in 3? I get 6, right? So you guys are thinking, well, I don't really need to know L'Hopital. I can just use the old way. What about this one? What happens when you plug in 0? You get 0 over 0. But in my first example, I was able to get rid of 0 over 0 using algebra. Now I can't use algebra, right? So we have to use L'Hopital's rule. So here it is again. You put a little h here. The purpose of that, it tells me or the grader, okay, you're going to perform L'Hopital's rule. So the limit as x approaches 0. But here's the kicker again. You do not use the quotient rule. You take the derivative of the top, independent of the bottom. The derivative of sine is cosine, sorry. The derivative of x is 1, and we're going to try the plug-in method again. If I get 0 over 0 again, I have to do L'Hopital's rule again. Okay, you can do L'Hopital's rule as many times as long as it's still 0 over 0 or infinity to infinity. So some of the harder problems, you have to do L'Hopital's rule twice, you know? Okay, what happens when I plug in 0 now? 1. You get 1 over 1, so the final answer is 1. Yes? You definitely get it wrong, yes. It has to be the derivative independent of each other. Because really what we're saying is who's growing faster, right? Here's another one. This one, no one questioned me on it, but if I plug in infinity, do I get infinity over infinity? I do. Now that we have more skills available to us, we can put a little h here. The derivative of e to dx is e to dx. The derivative of x is 1. I'll try plugging it again. So e to the infinity is infinity, and that's our final answer. Versus what did we have to do when we studied limits? We had to see who was growing faster, right? And e is always growing faster, so it's still infinity. It's just L'Hopital's rule is a bulldozer. Anything in its path, it just kills. It's really nice. As long as what? It has to be one of these two conditions right now. 0 over 0 or any infinity over any infinity. Now, I do have to tell you this, though. You don't always want to use L'Hopital's rule. Here's an example. The limit as x goes to infinity, 5x to the 7th plus 11x plus 1,000 over 10x to the 7th plus 12x to the 4th plus 2. This one is infinity over infinity. I could do L'Hopital's rule, but it would take 7 derivatives to get to the final answer. Versus if we do it the traditional way, how do we do infinity problems? Yeah, the most important thing, right? This guy's the most important, this guy's the most important, so my answer is 1/2, right? So even though it's an option, L'Hopital's rule, you don't always want to take it, because sometimes we have better ways. Does that make sense? Okay, grab your homework sheet. I'm sure on the back we'll find some limits, so let's see if I can find some here. Let's see. Okay, let's do this one as an example. What happens when I plug in 0? Bless you. 4 times 0 is 0. Sine of 0 is 0. 0 over 0. I can use it. Now, do you guys want a hint or no? No? Okay, go ahead and work this one out. I know, right? 4, 6. So the 4 and 6 are from the chain rule. We know the derivative of sine, but we don't know the derivative of sine 4x, so you have to use the chain rule there. So this part of the homework will have to the chain rule. My bad. I know. Lies. Okay, is it clear how you're going to do the limit part of the homework? Okay, and now we're going to start tomorrow's lesson today just because tomorrow is bang bang, it's a short day, and this lesson is going to be pretty hard, okay? So you can start a new sheet of paper if you want. Shoot, there's no equal sign there. Sorry. Okie dokie. The derivative of x is 1. And here's why, though. This is going to be a really long explanation, but would you agree there's a power 1 there? Right? The 1 comes down, x to the 0 power times the chain rule. And the derivative of x with respect to x gives me dx dx. What's x to the 0? And what's dx over dx have to be? 1, because they match, right? So the final answer is 1. You guys are looking at me like, why did you have to make it so complicated? Because the right side is complicated, okay? Let's try it again. 2 comes down, x to the first times dx dx. And we get 2x. The dx over dx is coming from the chain rule, the derivative of the inside, okay? The next one is 3x squared dx dx, which I don't need to write. Would you agree? The derivative of e to the x is e to the x dx dx, which is just e to the x. Derivative sine of x is cosine of x times the derivative of x with respect to x is dx dx, which is 1. So we don't need to write it. Good so far? Okay. The derivative of y with respect to x is called dy dx. It doesn't cancel off anymore. You see how this guy cancels off and gives me 1? The one on the right does not. Do you guys want to predict this one or no? Danielle's like, yeah, she wants to predict it. So go ahead and try it. Go ahead and work it out. Let's see what you guys get. Give it your best guess. Two y dy dx. Bless you. The 2 comes down. Y to the first times the chain rule. The derivative of y is dy dx. Did you guys get that right or no? Yeah, it doesn't reduce. We're stuck. Okay, derivative of y cubed is what? How about Santiago, Tanner, Thompson? What do you guys think? Yep. How about Rick, Aiden? What's the derivative of e to the y? That's it. E to the y, dy dx. Cosine of y, dy dx. Okay, is this making sense? Anytime you take the derivative of y, you must have a dy dx at the end of it, okay? That comes from the chain rule. You guys ready to try one? Find dy dx for this problem. What's the derivative of a circle? Questions on part A, B, or C? Yeah. Part B. So the derivative of x squared is 2x. The derivative of y squared, we just did right here. The derivative of y squared is 2y dy dx, which is right here, right? I need to get dy dx by itself because that's the goal, find dy dx. So I subtracted the 2x over in part B, and in part C I simplified it. No, the derivative of 9 is 0, right? The derivative of every constant is 0. Okay, let's have you try this one. Pause the video here. Okay, here we go. 2x minus 3 bracket. There's a product here. So product rule. First derivative of the second plus the second derivative of the first plus 2y dy dx equals 0. Aiden, did you get that? Yeah, if I check your paper right out, you got that. I didn't think so. You look so guilty. This is personally what I do. I leave the constant out, especially if it's a negative constant. That way I'm not carrying that constant in extra places. I'm not carrying extra signs. Now, this was on the review packet, the big review packet. How do you get dy dx by itself? We're going to have to bring that negative in now. These guys are going to stay put. The blue ones are going to get moved over to the other side. Does anyone remember what to do next? Yep, factor to dy dx. How about questions on A through E up here? Yeah. Because the blues do not have a dy dx, and my goal is to get dy dx by itself, so that's the first step, yeah. Okay, let's try another one, but I'm going to change it up. Let's do a tangent line one. So x squared plus 2xy plus y squared equals find the equation of a tangent line at 1, 1. Go ahead and work that one out. Did I record that? I did, okay. Did you guys get that for your first line? Yes. Derivative of constant? What should I do next? Huh? Yeah, we can do that. I don't know if, is there any, do I have another option or no? Plug in 1, 1, right? What's the goal of the problem? To find the slope. Are we better at manipulating letters or numbers? Look at all this work. That's not even done. It keeps going, right? So if it's a tangent line problem, there's no point in modifying the letters anymore, right? Because the final answer is going to be a slope. The slope could be 5. So plug in 1, 1. So 2 plus 2 bracket 1 dy dx plus 1, 2 dy dx. So I plugged in a 1 for x and a 1 for y. 2 plus 2 dy dx plus 2 plus 2 dy dx equals 0. 2 plus 2 is 4. And what's a 2 dy dx plus another 2 dy dx? Let's see. So the slope was -1, and finally I used the point slope formula to find the final answer. So if it's a tangent line problem, you're encouraged to plug in the numbers right away, especially if one of the numbers is 0, right? If one of the numbers is 0, things drop off drastically, and it just speeds up our work. Okay, so this is tomorrow's lesson. We're going to build off of that. I knew, I already know that tomorrow's not going to be enough time. Okay, tonight's homework is on this worksheet that was passed out. Let's see if we can identify it. Let's do 1 through 23 odd. '35 through 44 all. The 35 through 44 is going to be L'Hopital's rule, as long as it's 0 over 0 or infinity over infinity, okay? So odd, again, the first part should be pretty quick. It doesn't really require the chain rule, so you're practicing the power rule, product rule, quotient rule with trig. And again, I highly encourage you to start here. Take another 3 minutes to make sure you really know this, and then start the homework.